Hello everyone, I'm back. I've been a week in France. I ran 2 rounds of a relay race and my dog learned how to turn off my computer. But now I'm back. I've also been spending a lot of time working on a different project, which I'm not really sure what to do with yet. But for now, let's jump back into the bytecode compiler and try to make some progress. So just to remind you, we're following this book, Crafting Interpreters, and we're currently in part 2 of the book, and we're implementing it in Odin. So we already have quite a bit. Let's try to run it. So we do things like this, and it passes the expression we wrote and compiles it into bytecode that looks like this. So it will push 2 constants, and it will push an add operation and a return operation, and then it will evaluate this bytecode in the virtual machine. And the result is 3. So right now this is kind of in a debug mode, so it will print these bytecode instructions. But anyway, so we have a lot of stuff, but we don't have a lot of types. So let's take a look in here. This is what we have. We have constants, which is basically numbers. Then we have some operations on those, and that's about it. But now we should add some more types. We'll add support for 3 new literals, true and false, booleans, and nil. So we will simply add those like this. And then we'll see what's up next. So let's take a look at what happens if we try to run that. Let me actually open a new window here. We run it, and didn't compile because we have some switch instruction somewhere that, let me zoom out a bit, or let me do it like this, that requires us to make a decision about what we will do with about these new values. But let's try to follow along with the book instead, and first what we're going to do is add some stuff to the parser, which apparently we don't have it set up in exactly the same way. Let me see here. Right, so I guess it's here in the rules. Yes, so let's add it kind of in the same place. We already have false for some reason. Do we have true? And we also have nil. So we just need to modify these, I guess. So false, it gets a literal procedure for its passing. True also. And the same for nil. So when the parser encounters false and is a true in prefix position, it calls this new parser function. Okay, so let's make let's implement this function, literal, which will be just a procedure taking no arguments, and do a switch. So you see GitHub Copilot already knows about this code, which is funny. So when we encounter one of these guys, we will just emit a byte for this corresponding opcode. So that makes a lot of sense. Let me rearrange it like that. Although I guess it was alphabetical before, so maybe let's keep it anyway. So past presence already consumed the keyword token. All we need to do is output the proper instruction. Frontend can now compile Boolean and nil literals to bytecode. Okay. So now we need to go back to, let me delete all these harpoon things. Now we need to go back to the virtual machine and have a look at here. So we need to do something when we get a nil. And what do we need to do? Let's push it. Okay, so actually let's go back here, and we don't need these breaks because it's Odin. So let's remove those. And let's go back to the virtual machine. So if it's nil, we push nil. If it's true. Okay, so actually we don't want to push nil. What we want to push is a value nil. So we do like that, and then we'll push a false, let's say. Change this one to false. And here we'll push a true. All right. So that makes sense, I guess. We just put that value on the stack. Okay, so let's have a look at this assembler, which I'm surprised we didn't see here. Let's try to run it again. Okay, so we need to go back here, and we have to make this one a partial switch. Okay, now it just runs, which is funny. How? I completely forgotten where everything is. It's not here. Where is the disassembler? Is it here in main? There is something called disassemble. I cannot go to definition because it is not smart enough to do that. Is it here? No, that doesn't make sense. Is it here also? Ah, okay, it's here. Now, for some reason, my code looks a lot different. Actually, let me try something. So what happens if we run it and we'll say true? It just kind of works. So maybe we don't have to do anything. Right now, as I said, it's been such a long time, I kind of forgotten how everything works. So what do we do here? We loop over the code. We look at the instruction. We turn that into an opcode type, and then we just print that. And that's basically it. We just have to do something special when it's a constant. So that's fine. Let's try to run just true. Somehow it actually evaluates. Let's look at the print value function. We don't have that. How does it work here? When we interpret something, interpret. Okay, so it'll just set up the VM and then it will call run. And run just ends up printing the last thing. So that's good. Okay, yeah, so we cannot really do anything with this. We can just print them. We cannot add them. We cannot say we don't have an OR operator, for example. We cannot add them. Or anything like that. So this code will actually compile, but it will not run, which is kind of unfortunate in a way. Okay. What about this print? If we don't have print. No, but anyway, so now let's add, we're adding this this not operator. So let's add it here. And then we need to fit that into the parsing table. It's called bang, if I'm not mistaken. So we will pass it using the unary function we have. Maybe we need to, indeed we do, we need to fix it. Okay, so now we will simply emit this instruction, and then, but when we run it, we need to do something. Case not. So we need that value on the top of the stack. And let's see what he does, but I want to check whether it is a Boolean value. And if it is a Boolean value, then we will push can we do this? Let's try here. Okay, true, not true. So that didn't work, which is interesting. It's probably inside the tokenizer. Yes. So here I think we have to add this guy, and it has to be a paying token. Amazing. Actually, let's just test it also on false. Not sure what just happened. That also works. So we also did this one. So he actually has this isFalsy function, So let's also do that. So let's say new value is falsy on the value, and then we are going to just push the new value. So we need this is falsy function. I don't think we have to find that anywhere. No, it's only here. So it'll take a value of type value, and it will return a, suppose it should be a value again. So if it's a Boolean, then we simply, I don't think it's, is this even like a valid code? Doesn't look valid. No, so I think it's, yeah, it's like this up here. Switch the value in value. It's a little bit annoying, but okay. So it's actually not the value itself, it's actually more like the type. Right, so if it's a number, we'll say, is the number equal to 0? That means it's false. If it is a Boolean, then we will just return not of value. If it is nil, we will return, actually that should be nil. And we'll return true. And let's have a look at that. It did not work. Okay, so how do we unwrap it? Okay, so actually it works like this. You do the switch v in value, and then v is the thing you want. So let's do this, and then this. Try to run that. Okay, so now we should be able to say not true. We should be able to say not 0. Not 0, maybe not 0 would work. That works. So do we not support passing decimal numbers or something? No, we don't. So we only support integers right now, which is unfortunate. So let's add that. So do this. Once it's no longer numeric, we have to do something. We have to say if captcha equals, let me have a look at this, is numeric, how that works. Okay, so if it's a dot, then we do something else. Let's see how this make token works. Okay, we just need the string. So here we can say, yeah, we advance the tokenizer past the dot. Then if we're done, we just will make a number. If it's numeric, then we'll advance, so on, till we're not at the end anymore. And then I think that should do it. So now we can have decimal numbers. And there we go. Not nil. Okay. So I think let's say that let's say that's it for this video. So I think we're ready to get back into it for real. I will see you in the next one.